Now let's see the relationship between Ka and Kb for conjugate acid-base pairs. So we're taking as an example ethanoic acid. So for ethanoic acid, we can have a Ka value, a Ka expression for ethanoic acid. So pause the video, try to write it down. So you should get this expression. Now, if you look at the conjugate base pair of ethanoic acid, which is the ethanoate ion, so for the ethanoate ion, we can write an expression for the Kb value for the ethanoate ion. Pause the video, try to write down an expression for this based on the equation. So you should get this expression. Now remember, in Ka or Kb expressions, we do not include H2O because Kb is already a product of Kc and H2O concentration. So you do not include H2O here. Now let's combine these two expressions. Let's do a multiplication of Ka and Kb. So if we multiply the two, so try to multiply the two and see if you end up with the same expression as me. So if you multiply the two, you should get this, and you can cross multiply you can cancel out these four concentrations so that you end up with H plus times OH minus. So Ka times Kb gives you H plus times OH minus, and if you still remember, H plus times OH minus is equal to Kw. So Ka times Kb gives you Kw, an expression which we already looked at previously. Now if we apply logarithm to this expression, you can end up with pKa plus pKb giving 14. So if you know the pKa or the pKb value for any conjugate acid base pair, you can find the other value. So this applies for all conjugate acid base pairs. Now for example, if you need to find the pKb of the ethanoate ion, you can simply look for the Ka value of ethanoate of ethanoic acid. So 14 minus the pK of ethanoic acid. So if you look it up in the periodic table, you should get 4.76, so that the pKb of the ethanoate ion is 9.24. So this is how you can find it, and then from this you can find OH minus concentration, POH, etc. Now let's use this expression that we just found. So we can rearrange this expression here. So here, if we have a stronger acid, definitely we're talking about weak acids, but if we have a stronger acid, it means that it will have a larger Ka value. And if the Ka value is large, means that the Kb value is going to be smaller. And because the Kb value is going to be smaller, it means that the conjugate base is going to be a weaker base. So a stronger acid is going to have a weaker conjugate base. So this confirms what we have learned in topic 8.1, which says that a stronger acid is going to have a weaker conjugate base. Now this applies similarly to Kb. So if we have a stronger base, it means that the Kb value is going to be higher. Because Kw is a constant, means that the Ka value is going to be smaller. And because Ka value is smaller, it means that the conjugate acid is going to be a weak acid. Okay, so you're going to try out the next activity now.